some different type of quadrilaterals. Before that, we will discuss remaining examples of exercise 3.3. My dear students, in our previous session, we have completed most of the example of exercise 3.3. I hope you all understood. Have you written all the examples in your notebook? Yes. So let us start with remaining example of exercise 3.3. The example number 9 is, look at this figure. Here RRSK. Look at here RRSK and CLUE are parallelogram. Find the value of x. Here we given that these two parallelogram, they are intersect each other, and here we have to find value of x. Look at here, this x here R, S, K and C, L, U, E. Okay, that intersecting point here x. We have to find the angle x here. So how can we find this? Here we use the property of parallelogram that yes, opposite angles of parallelogram are equal, right? Opposite angles are equal. So for the parallelogram, RISK, angle K, RISK, here angle K and angle R are of 120 degree, right? Major angle R is equal to major angle R is equal to 120 degree, since they are opposite angles and opposite angles of parallelogram are equal. So here we get the angle R is equal to 120 degree. Now look at here, angle R and angle S. R and S are adjacent angles, right? R and S are adjacent angles, right? And if they are adjacent angles, we know that adjacent angles of parallelogram are supplementary. That means their sum is 180 degree. So here we can write as major angle I plus major angle S is equal to 180 degree. So major angle I is 120 degree. Therefore, so also I can write here 120 degree plus major angle S is equal to 180 degree. So here we get major angle S is equal to 180 minus 120, that is 60 degree, right? So major angle S is equal to 60 degree. Here we get angle S is 60 degree, right? Since they are adjacent angles. So here we write as adjacent angles, right? Now look at the next parallelogram. For parallelogram CLUE. Now for this parallelogram CLUE, angle L and angle E are opposite angles, and opposite angles are same since it is a parallelogram. Major angle L is equal to major angle E, right? So it is equal to 70 degree. So here we get angle E is equal to 70 degree. Now look at here, that E, we call this point as O. EOS is a triangle. EOS is a triangle. One of the angle E is 70 degree, S is 60 degree. So how can we find angle CO? Yes, using angle sum property. We already learned that sum of measure of all angles of triangle is 180 degree. So using angle sum property, we can easily find the angle S. Okay. So in triangle is equal to 180 degree. So how can we find major angle O? So major angle O is equal to what? 180 minus that 70 plus 60. That is minus 70 plus 60. So 70 plus 60. 130. 180 minus 130. So which is equal to 50 degree. But major angle O is what? X. So here we get the angle X is equal to 50 degree. Right students? Here we use two properties of parallelogram. Which are they? Opposite angles are same and adjacent angles are supplementary. Also here we use angle sum property of triangle. So you have to remember all these basic properties about quadrilaterals. Okay, all the quadrilaterals or all the polygons. We can say this as all the polygons. Right? Understood everyone? Yes. Now next one is example number 12. Here we have given this figure as PQRS. Is it is a parallelogram? No. Since here line SP is parallel with RQ. SP bar is parallel with RQ bar. But look at this side, QP and SR, they are not parallel with each other. Therefore, it's not a parallelogram. So it is a trapezium. Correct. Since only one pair of parallel line. So it is a trapezium. Now we have to find angle P and angle S. Major angle P and major angle S. So we have given that. They given us SP bar is parallel with RQ bar. Right? SP bar is parallel with RQ bar. Since SP bar is parallel with RQ bar, so P and Q are what? Adjacent angle. So therefore, P and Q are adjacent angles. And adjacent angles are supplementary. If it is also trapezium, adjacent angles are supplementary. So therefore we get major angle P plus major angle Q is equal to 180 degree. So major angle P is equal to what? 180 minus major angle Q, which is 130 degree. So major angle P is equal to 180 minus 130, that is 50 degree. So here we get major angle P is equal to 50 degree. Right students? Okay. Now again we have to find major angle S. Also SP is parallel with RQ. The line SP is parallel with RQ. Therefore R and S are supplementary angles. Right? R and S are adjacent angles. Adjacent angles. If they are adjacent, they are supplementary. Okay? That is major angle R plus major angle S is equal to 180 degree. But here major angle R is equal to what? This sign indicates major angle R is 90 degree. So 90 plus major angle S is equal to 180 degree. That means we get major angle S is equal to what? 180 minus 90. So it is 90 degree. Major angle S is equal to 90 degree. And here we find major angle P is equal to 50 degree. So students, you understood? Example number 9 and 12. Okay. So here we completed our exercise 3.3. Some of the few examples, 2 or 3 examples are remaining of this exercise. So my dear students, I hope you all finish this exercise independently. Yes, you can able to solve this example. Just watch the video and try to solve all the examples. Okay. Now we are going to learn some special parallelogram. Okay. In previous session we have learned parallelogram. What are the properties of parallelogram? Opposite sides are parallel and they are equal. Opposite angles are same. Adjacent angles are, yes, supplementary. Adjacent angles are supplementary. And diagonals of parallelogram are bisect each other. We have learned these 4 properties about parallelogram. Okay, now we are going to learn some different kinds of parallelogram. And first one is rhombus. First one is rhombus. Now look at these two figures, kite and rhombus. Now tell me your observation about these two figures. Yes? Look at it. In this figure, you observe that this side is equal to this side. Also this side is equal to this side. But in this figure, we look that all the sides are of same length. So this is the basic difference between kite and rhombus. Okay. In kite, only there are two consecutive sides or two pair of consecutive sides of equal length. This one and this one. Two pairs of consecutive sides of equal length. But in rhombus, all the sides are of equal length. So rhombus is a parallelogram having all sides are equal. Rhombus is also a parallelogram, but all sides of parallelogram are equal. Then only this parallelogram is called as rhombus. Okay. So rhombus has all the properties of parallelogram. That is, in rhombus, all sides are equal, right? So opposite sides are parallel. Opposite sides are parallel. All sides are equal. Opposite angles are same. Adjacent angles are supplementary, and diagonals of rhombus also bisect each other, right? So rhombus has all properties of parallelogram. Okay. Now let us discuss the diagonals of rhombus. Let us discuss the diagonals of rhombus. Okay. So for this, consider this rhombus A, B, C, D. Okay. Since rhombus is a parallelogram, okay, every rhombus is parallelogram. Since every rhombus is parallelogram, okay, opposite sides are same. So here we consider two triangles, triangle AOD and triangle AOD and triangle COD and triangle COD. Okay, now look at these two triangles, triangle AOD and triangle COD. Okay, now for this triangle, okay, first one, side AD is equal to side DC. Okay, first we get AD bar is equal to CD bar. Why? Since it is a rhombus and all sides of rhombus are equal, so therefore we get AD bar is equal to CD bar. Right? First one. Next one, look at it. Okay, AC is diagonal, AC and BD are diagonal, right? And diagonals of parallelogram are bisect each other. As rhombus is a parallelogram, okay, diagonals of rhombus are also bisect each other. That means here we get AO is equal to OC. Okay, so AO bar is equal to OC bar, since diagonals are bisect each other. And OD is the common line, common side between these two triangles, right? So we can write this as OD bar is equal to OD bar, since this is common. So three sides of these two triangles are same. So using SSS property, using SS side property, we can say that triangle AOD is congruent with triangle COD, right? Triangle AOD is congruent with COD. Using that test, SSS test, side, all three sides are equal. Okay. Now if these two triangles are equal, then their corresponding angles are also same. Okay. So from this we get major angle AOD is equal to major angle COD, corresponding angles. Okay. Major angle AOD is equal to major angle COD. Both these angles are equal. But look at here, angle AOD so measure of these two angles is 180 degree and these two angles are same. That means what? Okay, measure of these two angles are same and sum of this measure is equal to 180 degree. That means every angle, that is measure angle AOD and measure angle COD is of measure 90 degree since they are same and they are linear. So measure angle AOD is equal to measure angle COD is equal to what? 90 degree. Okay, that is here we get these two angles are 90 degree. That means what? From this, what we can say about the diagonal of rhombus? Diagonals of rhombus are bisect each other and also they are perpendicular to each other. Right? Look at here. This angle is of 90 degree. This shows that diagonals of rhombus are bisect each other. Also they are perpendicular to each other. So what can we say about the diagonals of rhombus? Diagonals of rhombus are perpendicular bisector of one another. Right? Diagonals of rhombus are perpendicular bisector of one another. That means they are perpendicular to one another. Also they bisect each other. Okay students, do you understood? This is very important property about rhombus. Rhombus is a parallelogram, but only difference between rhombus and parallelogram is what? All sides of rhombus are equal and diagonals of rhombus are perpendicular bisector of one another. Okay, understood? Yes. Now next one, RICE is a rhombus. Okay, RICE is a rhombus. Find the values of x, y and z. So look at here, x, y and z. So here we use the property that since they have given us this is rhombus, so all sides are equal. That means here the side ER is equal to the side RI, right? Since it is a rhombus, we can write as ER is equal to RI, but ER is equal to 13, so RI is equal to also 13. So here we get value of Z is equal to 13, right? It's very simple. Also, diagonals of rhombus are bisect each other. So therefore, we can get as OI is equal to OE. OI is equal to OE and is equal to 5. This is value for x, right? And also we can write as CO is equal to OR, but CO is equal to 12 centimeter and this is 5. So we get y is equal to 12. So it is very simple example, just using the properties of rhombus. Okay. Now next special type of parallelogram is a rectangle. Special type of parallelogram is also rectangle. That means what? Rectangle is also a parallelogram. Rectangle has all the properties of parallelogram. Okay. So look at here. Rectangle. Okay. That means if a rectangle is a parallelogram, opposite sides are parallel. Also opposite sides are same. Right? Rectangle is a parallelogram. So opposite sides are equal, opposite sides are same. Opposite angles are also same. Adjacent angles are, yes, adjacent angles are supplementary. And diagonals of parallelogram are bisect each other. Diagonals of parallelogram are bisect each other. So now here look at it. All the angles of this rectangle x degree, x degree, x degree, x degree. That means they are all same. All the angles of rectangles are same. So what is the degree of every angle? Since it is a quadrilateral and all of you know that sum of measure of quadrilaterals or sum of measure of all angles of quadrilaterals is 360 degree. Angle sum property of quadrilateral. So we can write as 4 times x plus x plus x plus x. That is 4x, right? So we can write this as 4x is equal to what? 360 degree. Now 4x is equal to this is the difference between rectangle and parallelogram. Okay, in rectangle parallelogram opposite angles are same, but in rectangle all the angles are same and they are of 90 degree. Measure of every angle of rectangle is 90 degree. Okay, now consider the triangle A or ABB and a triangle ABC. Consider the triangle ABB and triangle ABC, right? ABC and ABC. Okay, so look at these two triangles. This ABB and the triangle ABC. Now for this triangle, AB is the common side, so AB bar is equal to AB bar, right? For the second, here AB bar is equal to BC bar, since opposite sides are same of rectangle. Since AB bar is equal to BC bar, AB bar is the common side, AD bar is equal to BC bar. Also the angle is major angle A and here the major angle B is same. That means BAB, third one, angle BAB is equal to angle ABC. Angle ABC, since all the angles of rectangles are 90 degree. So these two angles are, this one angle, this and this. These two angles are same. So look at here, this side, this angle for the triangle. Look at here. This side, this angle and side. That is side, angle, side. So using side, angle, side property, that is SAS, side, angle, side property, we can say that these two triangles are triangle ABB and triangle ABC. Both the triangles are congruent triangle using the property SAS. So if the triangles are congruent, their corresponding sides are also same. So here we get the corresponding side AC is equal to BD. Okay, AC bar is equal to BD bar. But look at here, AC and BD are diagonals of rectangle and they are equal. So what is the property of rectangle? Diagonals of rectangles are bisect each other, since rectangle is a parallelogram and diagonals of parallelogram are bisect each other. Therefore, diagonals of rectangles are also bisect each other. But what is the property? That diagonals are of same length. Okay, diagonals of rectangles are bisect each other and they are same. Okay, so look at here. Here ERTN is a rectangle. Okay, ERTN is rectangle. Okay, here we have given that these two length and we have to find the value of x for this. How can we find this? Since we have learned earlier that diagonals of rectangle are bisect each other and they are of same length. Since they are bisect each other and having same length, that means these two sides, that is OR and OT, are equal. Since all these OR, RT is a rectangle, so we can write this as OR is equal to OE is equal to OA is equal to OT. All these sides are same, since they are of same length and they are bisect each other. Okay, so from this we can write as OR is equal to OT. OR is equal to OT. So we get 2x plus 4 is equal to 3x plus 1. So now all of you know how to solve linear equation. Okay, just transposing 2x to this side and 1 to this 3 this side. So 4 minus 1 is equal to 3x minus 2x. That is x is equal to 3. Okay, so in today's lecture we have some remaining examples of exercise 3.3. Also some special type of parallelogram, rhombus and rectangle. Rhombus is also parallelogram. It having all the properties of parallelogram. But what is the basic difference? All the sides of rhombus are same, and diagonals of rhombus are perpendicular bisector of each other. Also, in rectangle, opposite sides are same and they are parallel. But all the angles of rectangles are of same measure and they are of 90 degree, right? And diagonals of rectangles are bisect each other, also they are of same length. Okay, so there are some different properties for every quadrilateral. Okay, so you have to remember all the properties. Okay, up to this we have the trapezium, then kite, parallelogram, rhombus and rectangle. Okay students, you understood all? So write down all the exercise in your notebook. Also watch the video and after that make your notes. Okay, have a nice day.